Last part of this lab, we're going to be going over the report and the document, and we're also going to be looking at an oscillator. So by adding a resistor and a capacitor to the comparator with high hysteresis between our Vout and Vin, an oscillator can be built, and the output voltage will constantly switch between the voltage OH and the voltage OL, and this frequency set by the RC time constant and the OH and VOL values are used. So we're going to design this circuit in figure 8. We're going to set the frequency of our oscillations to be 5 kilohertz, and then we're going to use the same 1 volt high and low reference levels that we use in 7. So it's going to be very similar to what we've done here. The only difference is that for our Vn, we are going to be now adding a capacitor. And after this, we are going to be, so a capacitor is here, and then we have a resistor that's going into our Vout. This resistor is a little bit interesting because we're not exactly given a value here, and I'm not sure if my partner put a resistor, so we might not even put a resistor here. And then we have our R2 and then our R1, which I know my partner did put a resistor in for. This is not going to change because if we look back at 7, we have this resistors here as well. So the only thing changing is the capacitor and this resistor right here to our Vout. So if we look at our number 8 oscillations, we just have the document and we have notes, we have our calculations, which we are very unsure about, it seems. And so just looking at this, he says 32 nanofarads, but I am still going to use the, I think it's 4.70, something around there, 4.7 something nanofarads of capacitance that we've used previously. And so now, with that in mind, we can look at the interview question. If the high and low reference levels were changed, how would this affect the frequency of our oscillation? Well, if they were changed for our reference levels, that's what we're going off of, and that's what we found previously here. My thought would be that they would have to be either increased or decreased. So if our reference levels go higher, then we are going to have a it would have a greater frequency, and same thing with the other way, the reference levels low, but in the opposite direction. And so now with that, we can look at our breadboard. Looking at our breadboard, we have the following circuit. Make sure that our wavegen is off before you start doing this, otherwise we might have a short circuit. So our connections, we're going to check them. Let's remove these wires so that we get a better look at our breadboard. And so inside of here, we have our voltage positive. We have our R1 going to ground, so this is not going to change. This is going to be the same resistor that we used last time. It's a 1 kilo ohm resistor. And then we have these 2 kilo ohm resistors that are connected in series, 2 kilo ohms each, so that makes a 4 kilo ohm resistor. And then we also have a capacitor and a resistor that we're adding on top. Now, I, again, and my partner seem to be very unsure about this resistor, so we're just going to add the capacitor and see how that looks. So capacitor is about 4.7 nanofarads, and we're going to take this little guy and we are going to connect it from the ground to our Vin, and we can see that from the little diagram we have here. And our ground is going to be the negative rail right here, and we need to connect that. We need that to get to the V negative, which is that second pin right there. And so what we can do is extend the leads a little bit, and we are going to go, in fact, instead of extending the leads, since this is so long, a good trick that we can use is just finding an empty column and terminating it into there. And so now that column is going to have our value. And so what I'm going to do is actually grab a jumper wire, and I'll just grab a white one, and I'm going to go from here into our ground. That way we are going to ground out this capacitor, and so that is going to be our values. Now we want to measure our voltage output, so this is going to go here. Our voltage input in this case is going to be the capacitor part, so we're going to take this wire and we're going to put it in the same column as our capacitor. And so this is what our circuit is going to look like. We can see all the pins very carefully put in, And again, the capacitor, it's going from our ground with this jumper wire into our VN. And then we have our VP. We have the same thing as the last video. So that is in there, and that is linked in the playlist below the like button. So now we can, after looking at this circuit, go back to our waveforms. We are going to turn our wave gen 1 on. We're going to turn our scope on. And then we're going to turn our master enable on. We can see that we have a 1 volt here and then a negative 1 volt here. And we want to change the kilohertz to be 5 kilohertz. So we'll change that. And then I'm not sure if we still want to use a triangle wave, but we'll try sine. It does not seem to make a difference, so we'll just keep it at triangle. And then we have 1 volt high, negative 1 volt low. Try making it 5 volts. We can see that it just separates and then it starts going crazy. So let's change that back to negative 1 volt and then 1 volt here. And we can see that they're very similar. With millivolts, we can stop and examine it. Yeah, very similar. And it's just going to continue to oscillate. So with that in mind, I believe we have done this correctly, and that is our lab. Now, for the document, there are a few things that we missed. Obviously, I was not able to put my results, all of them, on here in time, and we did not complete it 100%. However, we still got credit for it because of everything that we had done so far. Now, there are a few things to note that we can improve on, and that is the actual documentation style. So we can see that it is in the horizontal mode. We want it in landscape mode. That way the images like this, they're spread out more and we can read the data a little bit more easy. We can also shorten these paragraphs because we probably don't want to read all of this. We want to also write about what we are measuring in part B, not a huge paragraph again here. And then for our PSpice waveform, we want to use all of the space. If we look at our waveform, there was for one of them that had some space, some dead space. I think it was at the very beginning, and we just want to make sure that we use all of the space like how we had here. And we can close some number boxes on the bottom and only the relevant ones, and actually list percent error as well in this part right here. So we did calculations but not percent error. But other than that, the lab was good. There's some things we can improve on, and that is it for this lab 1.